I'm Derek Dimery, and I'm going to be going over the SPICE system. All right, next slide. What we're going to be going over is the agenda. It's to establish initial needs of SPICE. It's going to be listing the objectives, identifying the stakeholders, explaining the key functions and how they interact. And it's also going to be going over a list of the requirements that were given over how SPICE was supposed to be conducted. Next slide. What you're going to see first is going to be showing you why SPICE was asked for in the first place. What you'll see in this slide is an interconnection between all of the production centers, connecting to each and every other production center, also connecting to each and every customer individually, and connecting to each and every collection system. And you'll see that for every single production site, you'll see that for every single collection site, you'll see that for every single customer. And the problem with that is that you have no interconnecting links between these nodes, so it's really hard to track and manage what has been done, who's done it, why they did it, and what the priority of that mission was. And so that was the main driving function for why we are trying to produce SPICE. SPICE is going to be the single point for incoming requirements from all the customers that are asking for our support. But it's also a single point for all of the production elements to actually receive the tasking, get their priorities, and provide products to the end customer. It's also going to be where the production centers ask for additional collects from all the collection systems, and it allows for metrics to be actually completed by management to ensure that they understand what's going on with the products, making sure that they understand that everything is going to be fed and how it's going to be managed. So next slide. What we're going to see in this next slide is your OV1. Your OV1 is going to basically kind of go over what I was explaining, which will you have your RFIs or INs coming from your customer, and then it'll go into with a blue line going into the management. The managers are going to basically make sure that they understand what's being asked of the system, making sure that they understand what each component of the request is. This is going to be called an EEI, which is an essential element of information, which is going to basically be like the smallest minute part of each of the request. So you'll have a request with many EEIs broken out into it. What the management will do is then identify who the correct production center are. There are many. And then it will give it the product or give the RFI to the production center. The production center will identify what they need as far as do they already have existing data to support the request, or do they need to request more? If they have what they need, they will go in the yellow line with their final product and present that to the warehouse. If they have additional needs, that'll go back to the management system, who will then rack and stack and prioritize, and then give that to the one of many collection sites or many collection sites. Each of the collection sites will then try to identify the specific EEIs that the production center needs as far as the data is concerned. And then whenever they have their product, they too, like a production center, will feed the warehouse. The warehouse will then be picked up by the customer. In this case, it would be the production center. The production center will incorporate that into their final product, and it'll go into the warehouse. From the warehouse, what you'll see is it will leave the system boundary, and it will actually go to the customer. So what that's going to entail is there's an alert system we'll get into later, and but once it's given to the customer is outside of the system. Next slide. The next thing we're going to try to do is list some of the objectives. So one of the things is going to be the reduction of man hours it takes to do the management. As we saw in the first slide, one of the biggest problems with not having SPICE is that there is no link between the nodes, and management decided that they needed to know what was going on with all of their subordinate organizations, so they needed a way to centralize it. What we're also going to try to do is improve uptime of collection resources. The reason why that's in there is because after we started doing some research onto the entire system, we started noticing that there was a big discrepancy. Almost 75% of what was being collected at a collection site was at a misprioritized it was at a priority different than what the management was prioritizing. In other words, they were collecting something at a lower priority at a higher volume and a high priority at a lower volume. And so they weren't necessarily meeting all of the criteria necessary for the optimization of their work center. What we've also found during our investigation was we're trying to reduce collection errors. And that is going to be the quality of what is being collected. It's also going to be show you like a production center asks for a specific type of data and they receive something that was either the incorrect or didn't meet the quality controls that they were wanting. And so they couldn't use it, and so then we have to reattempt it. Any reattempt is, of course, going to add time. Next slide. So now we're going to be going over the stakeholders. The stakeholders for this system are going to be in blue. You're going to see your primary customer sets. That's going to be your IC partners. That's going to be your joint services. That's going to also be your intra-service customers. Those are customers who are already within your service who are asking for support. That would be like a production center asking a collection center for additional collection. Outside of that, you're going to see your orange, which is going to be your production centers, which we've covered. We are going to be your collection centers and your configuration managers. Your configuration managers are throughout the system, but primarily focused around the collection center piece. And their main role is to ensure that the collection systems are set up to collect the highest priority and maximize the resources at each collection site with what their given tasks are. And then, of course, maintenance. Maintenance is throughout the entire system. Everything breaks down, everything needs to be maintained. And then in black, what we have is your management functions. These are not production, they're not part of the requesting, but they're there to ensure that the system as a whole is getting the prioritization of their missions, functions answered. And then there is security. Security is also part of the system. Their main part is to add red tape and to more or less get in the way. Next slide. The next slide is going to go a brief overview of everything in a graphical format. You're going to have your OV1, which we've already seen. It's going to talk about your scenario, which I've already covered with the first slide. And it's also going to talk about the mission. The graph in the mission section is a little bit different than the OV1 in that it breaks down what the actual management functions do. It talks about the specific documentation that they provide, and it goes into a little bit more in detail into what the functions of each role is and what the systems that they use to accomplish this. So it kind of shows the systems of systems approach and showing that it's more than just the SPICE system, but it's actually all interconnected systems that work together. Next slide. So the next thing we're going to cover is the production entity diagram. What this kind of breaks down is going to talk about SPICE as the overarching system, but then it's going to talk about some of the actual entities within it. So for example, your production center has to make the products that you're looking for need an analytical suite. The analytical suite consists of many components. The components are tools, which are mostly software-based, the computers in which those software-based tools are on. You're going to have your networks, which consist of like routers, and your authority to operate, which is going to be security, basically saying here's some red tape that you have to jump through. And it's going to talk about your manpower. Your manpower is a part of the system. It's going to be the training aspect of the manpower system, which includes like certification and making sure that they meet the timelines in which they're authorized to do their training. You're going to have your QC process. This is harkening back to the EEIs and making sure that before a product is submitted to a customer, each EEI is addressed. Even if it's, we don't have enough information at this time, at least each EEI is being addressed to the customer as it asks. And then of course, your authority to operate. Underneath your collection, you have your collection hardware. This will be anything that receives what would be considered collection. it would be a system or components that will receive data and convert it into a useful format for analysts to later use. You'll also have your configuration management. Your configuration management have your individual components, which will need to be databased, and then you'll also need computers to reach into those databases. You'll have your a configuration management resource log, which will basically say, okay, here is what our schedules are, here is our various configurations, how do we maximize our uptime with the various configurations to meet the highest priority tasks. Underneath management, you're going to have mostly computers, because management is going to be mostly going to be using Spice and using the alert system within Spice. You're also going to have your warehouse. Your warehouse is where everyone is going to be storing the data that's going to be shared back and forth. So you'll need servers to store all the data. You'll need database information. What that means is a way to kind of query the database and make sure that you can find what you're looking for. You're also going to have your authority to connect, and you're also going to have your networks, which is again going to be routers and your authority to operate. Next slide. So the identification of the key functions. So this chart is supposed to show you the RFI and how it goes into the system, and what shows prominently in this diagram is the fact that just about everything is going to be conducted through what we are calling the alert system. The alert system is going to be how everyone is tipped off that a new request has entered the system. It's going to show what the priorities are when a manager has actually validated it, who the manager has tasked. It's going to go to the production center, who will then make their product or make a request, and which will then alert the managers through the alert system. Collection will do very similar things. They'll take their priorities and whatnot through the alert system, and it will then be documented throughout their processes. And everything will eventually go to the warehouse, and the warehouse will then have their whitelist, making sure that they know who their customer sets are and who they can deliver the products to, and then that will alert the customers, who will then receive the product. Next slide. Your functional flow block diagram is what we're going to be looking at next. I've broken this down into two tiers to make this a little bit easier to read, but in your operational first view, you'll see what we're kind of talking about as far as the generalized functions. So you'll have your RFIs and INs, you'll have your validation, you'll have your tasking, production, collection, warehouse, and delivery, all being fed to your alert system. Now you'll see a dotted line kind of going off of that, because we're going to kind of define what all of those interconnections mean in a lower view. But basically they would all go to the alert system. The alert system is consisted of a default notification system, a customer notification system. So what that is trying to specifically go into is users will have the choice to set or uncheck the various notifications. This kind of allows it so you don't get spammed by all the notifications, and you're really just trying to get what you want. We're also having the hierarchy of notifications. So this will be if your subordinate organization makes an update, you can opt into those type of notifications as well. So it's not just your organization, it's not just people who receive things from you, and it's not just things owed to you, but it's also who belongs to you. You can opt into those kind of notifications. And then you have your alert list notifications. That is the specific function that will go into the home page, which will actually tick off like, hey, you have an alert. Here's what this alert means. You'll see the solid blue lines go to the home page, because the home page is going to be the default way in which everyone's alerted to everything going on within Spice. You'll have a dotted line going to the alternative alert system, and that's something a user can opt into. If, for example, they don't primarily use Spice, they use whatever system they're currently using, they can opt into and set up a way in which the alert systems will be routed, similar to how you would have your phone send your work emails to your phone so you can check emails at home. All right, next slide. What you're going to see here is your operational fourth level. This is going to kind of show you the processes in which we've already kind of covered, where you have your RFI, validation, and tasking flow, but it's going to show the kind of various blocks that are involved in this. What you'll also see is it'll go to your production center. Your production center will create a collection RFI, and then it'll kind of flow through the same thing. The OR is what's there for. You'll see the dotted line going to the collection because not every requirement is going to require a collection requirement. A collection requirement will eventually feed the warehouse, similar to how the production goes to the warehouse, and the warehouse will then go to delivery. Underneath your operational fifth level, you'll have your whitelisting, which we've already kind of covered, which is basically making sure that the people who need to receive it can receive it, and making sure that people you don't want to receive your product aren't allowed to. We are also going to see your Eei Complete Checklist. This is referring back to any production or collection where the EEIs will be broken down into clickable boxes saying, hey, I answered each one of these EEIs. It's a way of QCing or automating some of the QC process. And then, of course, there's a security review, which security mandates and constantly updates various aspects in which they want to review the products that are leaving. It depends on whatever the security du jour is. Underneath the maintenance level, kind of applies to almost everybody, but the blue line will show the collection, and that will show that the maintenance is a big part of just making sure that the equipment stays up and running. You're also going to have your scheduling system, which we talked about trying to optimize what your resources are focused on. And we're going to have your configuration management. And your configuration management ensures that the optimized collection is actually what's currently the collection system set up for. And that's what you'll see the dotted line for. In orange, you'll see the maintenance and analysis as key functions of what the production center provides. Next, we're going to be going over the functional packaging. And on the blue side, we have all of the requirements, and we have lines tethered to the actual different functions. And then the functions will be going to the tasks in which are actually being conducted. So as an example, we have at the very top, we have share products through connected production databases. So what that's referring to is mostly the warehouse. So you'll see a blue line connecting to the warehouse function because it's the databasing of the products. And then what the warehouse function is doing is it's using computers as one of its resources. It's connecting to the servers which store the data, and it's using user authorized indexes. So it's allowing you to search through and find actual various pieces of what you're interested in getting out of the database. It's also showing you database information. So this is going to be the actual pieces of data that you're going to be receiving. And of course, it connects to various networks, because if you can't get anything off of the system, what would be the point? And it goes through each of the requirements. Next, we're going to have your N2 diagram. So an N2 diagram is a systems engineering diagram, in which case it shows the linkage of what's in the system and the key functions. For us, it's the alert system management, production, collection, and warehouse functions, which you'll see on the diagonal. And then what you'll see outside the system boundary is your external interfaces. This will be your RFI requests. This will be the feedback from the customer. That's what your E1 and E2 are. As far as your warehouse, that's going to be an external because it's delivering a product to a customer who's outside the system. So that's what all of those are. What you're going to see on the top right-hand side of all the boxes is a connection between one function to another function within the system. And this will be what the top function, in this case, analysis system, is going to be delivering to the management system. And the management system is then going to, which you'll see like I1, for example, an internal one, which is your interface interface with the alert system. So a requirement will come into the alert system. The alert system will then give, because it's on the top view, down to the management system, hey, a requirement came in. A requirement will then be validated and tasked by the management system, which will then be fed in your I1, because it's now on the left or bottom side, and be fed up to the alert system saying, hey, I have now tasked and validated this one. Alert system, here's what we've been updating. And that'll key the alert system to go to its next thing, which will be the production system, which will also have an I1. And you'll see that a flow throughout the entire system and all of the external and internal interactions between all the key functions and all the key players. All right, so what we have on the left-hand side is your N2 diagram, and what we have on our right side is your SBD. And so what you're going to see is basically two different functions that are going to say similar information. But what this shows you, what the SBD shows you, is the linkages and direction in which the information flows. So for example, we have your alert system. Your alert system, who all has black connecting, if they originated, I tried to show that it would be, the arrows would be in that color. And you'll see that the alert system will talk to the management system, but the management system will also talk to the alert system. The alert system will also have a dotted line that goes outside the system, and this is going to be alerting customer set saying, hey, you have a new product. Remember earlier we said that a customer set can opt into an additional alert that's not necessarily within Spice. That's what that's referring to. You'll see connections between management systems and production systems, management systems and collection systems. This is going to be primarily your tasking. Your production systems will be warehousing their final product, and the warehouse systems will primarily be focused on delivering the data, or in the final product. Next slide. This is going to be your interface management working group. So the key part of this is a working group where you have experts who can all chime in and help the system along the way. They will basically represent the various functions in which they serve in the system. We have an entire list over here, but we have like the lead engineer, which will be myself. We'll have a customer representative, which will be Bob Seeger. He's a customer that we deal with quite regularly. We have a request writer. So oftentimes a person who needs the information isn't the best at explaining the nitty-gritty details of all the things that they want. They'll usually say, I want to know everything about everything. Your request writer will actually say, here's what we mean by that. You'll have your lead engineers. Often these are the people who would use the information. You'll have your warehouse database. This is going to be, your DBA will be primarily primarily focused around receiving and making sure the database is optimized, making sure that everyone has what they need. Let's see, your security control, that's going to be your security. They're going to make sure that all the red tape is in the right place and that nothing gets done quickly. You will also have your network developer. So your network developer, he's going to primarily make sure that everything is connected to what it's supposed to be, how it's supposed to be, and make sure that all the systems are talking to each other the way they're supposed to. Next, you're going to have your CEO. Your CEO is going to be your main manager, making sure that the overall system is performing what it's supposed to. Under that one, you'll have your management lead. That will be primarily the people who are focused in on tasking or making sure that prioritization is meeting the intent of the CEO's intent. We have lead reporters. This is going to be underneath the production center. This is going to be a person who makes sure that all the productions is going to be actually written in the first place. You're going to have your collection site. So in this case, we're using collection site A, which is Carlos Santana. He is one of the more frequently tasked collection sites. We have your configuration manager, basically making sure that all of the collection from collection site A is configured to the best capability of getting the highest priority at all times. And then we have your warehouse manager, who's primarily focused on making sure that the data is being stored correctly, the whitelists are being managed correctly, and making sure that the products being delivered to the customer sets are all being managed and taken care of. Next, you're going to have your requirements, and there's a litany of requirements. There's 10 requirements that we're going to be covering over, which the first and primary one will be your SPICE shall connect to DoD networks. This is a requirement from the customer set, and this is a necessary requirement because if it's not connected, no one's receiving anything. Implementation independent. I apologize, my slides have blended a lot of the words on what I'm trying to look at, so I had to actually try to decipher what it was saying. That is in regards to, is this the only requirement that will be executing on a specific thing? We have a completeness requirement, whether or not what's being asked for is everything that's needed to make sure that this requirement is being satisfied. We have singular, making sure that this requirement isn't also being covered by other requirements. We have verifiable. This is, of course, necessary to make sure that anything being requested, you can actually prove beyond a reasonable doubt that what you're providing will answer that need. Correct. This is making sure that the requirement actually answers all of what it's supposed to, and that it is performed in the way that it needs to. And so for example, this one, SPICE. SPICE receives requests from the customer only through DoD networks. We have a citation to Kern 2020. SPICE delivery of the products is only authorized over DoD secure networks. In the fictional online, Joe Dirt 2022, he was able to identify that all networks outlined traverse the DoD approved networks and conform to the appropriate classifications and guidelines. So what that basically says is that we went out, we did a survey, we made sure that all the connections that we already have established connect to the ways that meet the security guidelines and meet the intent of the DoD required networks. All right. Your requirements continue on. The next slide. For example, we have a SPICE shall conform to the RMF policies. This is the referring to the security du jour. What you'll notice here is unambiguous. It was not checked. That's because, like I was kind of alluding to, security criteria is always changing. Once you think you've finally checked all the boxes, they decide that those are no longer the right boxes and that you need to start over from square one. But you'll also see, verifiable. It's really hard to verify that you have conducted what you need to a security level when they're constantly changing all of what's required. What you're going to see over here is going to be, your next one is going to be your time cost metric gathering. This is going to be your primary focus of why SMART was being requested in the first place. And what you're going to see over the period of time between the various OVs that we're going to be going through with SPICE, that ultimately we have in orange your MVP, your minimal viable product, and your operational viable product, which will be your blue line. And you can see that once we actually start implementing and changing the SPICE network, we actually believe that within the second or third iteration, we will be meeting the minimum criteria. And within the second iteration, if we can get everything online the way that we hope to, we will be meeting the OVP. Next, we're going to be covering down the collection centers And this is going to be covering the need to know what the priorities are throughout the entire system. And what you'll see is kind of a steady and, this is going to be covering the downtime. So the downtime is going to be very hard to bring down. As you see, it's kind of like a linear digression, because ultimately every feed change or every swap that we have to do is going to require a minimum amount of time of usually several hours. The goal is to do 1 hour in a week. So that would be at most 1 feed change to meet all of our needs. And so if you don't optimize your system, it's really hard to get below that. What we're currently dealing with is a feed change about once a day, once every other day. And so if it's an 8-hour feed change, what you're going to see is a 4-hour average on the days in which you're trying to do your collection. And so it makes it very difficult to bring that down in a normal way. But we believe that near the last iteration of Spice, we'll have maximized the connection and communication between the management systems, the collection systems, and the configuration management. Last slide, the number of errors. The number of errors is going to be your most dramatic decrease in time. As I alluded to earlier, there was a 75% difference between the prioritization in which things were collected and how it was being tasked. We think that within the initial Spice delivery, it's going to be significantly lower, because we're talking about 15,000 collects, 75% of which are going to be incorrect. Once you actually provide Spice, it should provide an immediate change in all of those priorities, because everything is being centralized. From that, we believe that the further iterations of the system will then bring that number down. And as you see, a near zero amount of errors will be what we're aiming for, pretty much limited only to human error. What you're going to see over here is just summary of all 3 of those graphs. All right, requirement allocation. So the very first one that we talked about was the Spice management tool, basically trying to find a better way to develop MOPs and MOEs based off of the metrics, and instead of having to go to 1,000 different networks to pull off various pieces of information, hodgepodge it together and try to make your best out of the data that you receive. What we're going to see is your management system. And you're going to see that it's going to rely primarily on your compile speed, which has TBD because the system isn't online yet. Your data fields presented, basically that's a yes or no type of metrics on whether or not that's successful. If you're query capable, so if you can query what you've actually put onto the system, that will be a success. Your availability is another key component of identifying whether or not you're being successful, and we expect an almost 99% uptime. There will always be an unexpected outage, but largely that's what that's going to be. We have your production to analysis, which is going to be your refresh rate is going to be a big problem, because making sure, not a big problem, but it's going to be something that we need to concern ourselves with, because we want to make sure that everyone is using the same information from Spice at the same time, and that they have the most current up-to-date information at all times. Availability will also depend on networks, depend on locations, and then we have the various units. We have the reliability of the specific unit the production centers are going to be using. We have the maintenance. We are looking at a 0.7 maintenance, which will be like about the effort will be 30% of your time is going to be used maintaining it. This could be something as easy as taking it offline, doing your maintenance, putting it back online, and then hot swaps. And then we have the cost of the unit A, which is about $1,100, and there are various tools. These are the tools that I referred to earlier, where you'll need a specific license. which will cost like $150 per license. You'll also have your maintainability. This will be the difference between making sure that the analyst tool is updated or that the current latest version was pushed onto their systems. And then the reliability, high reliability for these particular systems because there's not a lot of moving parts. And then, of course, the production elements also need to have good connection, both to our system, but also to their own systems. You'll have your collection to analysis. This is going to be affected primarily by their connection, making sure that they're updating the analysis systems and tools, and making sure that they have connection to SPICE. The collection systems will also have units. The unit for this collection system is roughly about $115,000. This is a high impact tool, and it is in very high demand, but it's also maintained and managed and very limited supply. You're going to have your management. Your management is going to make sure that everything is coming in through SPICE. So you're going to see that the refresh rate is currently TBD, but we expect that to be near null because they will be on SPICE, making sure that SPICE is updated. So if they can't connect to it, then, or whenever they're updating it, they should immediately have the information go out. And then we have the warehouse system. The warehouse system is going to make sure that, hey, for example, Unit A, that's going to be for example, a server farm, which for this particular server farm is being estimated at a cost about $30,000. Requirement allotment 2. This is going to be primarily focused around your collection systems to minimize downtime. So you're going to see your collection system and the various metrics in which we're going to be using to ensure that they're doing the correct thing. Your configuration management is going to be, your configuration 1 is going to be a specific set of tools that you're going to be receiving information from. What you'll notice is that for this particular timeline to set it up, the cost is not in dollars, but it's in hours. So if I need to switch to configure 1, I need to understand that that means I'm going to spend 8 hours of downtime on my collection asset. Your configuration 2, however, is only downtime of 5 hours. But the difference is that the percentage of numbers of tasks of what's been asked of configuration 1, you're going to get about an 85% solution. Where you differ is about a 15% solution over your configuration 2. That isn't to say that the 15% is mutually exclusive of the 85%. It is merely saying that 15% of the overall list of what you're trying to collect is being covered by configuration 2. And then your configuration 3. This is usually a very high demand, high priority, but it's a very limited scope on what can be collected. That's why you'll see about a 5% of the tasks will actually need this configuration. Why the configuration maintainability is really high is because of the lack of the infrequency of being used compared to the other resources. But you'll also see that its cost and speed change will be like a 2-hour cost. Its availability will be up fairly often, but you'll also notice that it is far more expensive than the other ones. And so these are all ways in which we try to measure the effectiveness of all of these things. All right, and in your requirement allocation 3, we're going to try to be covering the rate in which the error rate in which we have to deal with a lot of these things. So we're going to have a scheduler is going to be your primary function, and its connectivity is very high. Its availability is also going to be extremely high. You'll have your configuration management who will be connected to your scheduling apparatus, and you're basically making sure that 95% of the time, you'll know exactly what components are being used on any type of configuration at any particular amount of time. We have in here a number of days forecasted. We're expecting to be at a 9-day forecast. So if you within a 9-day gap, we know all of the tasks that are going to be levied against any particular collection site, and the configuration manager will try to optimize uptime against all of those various collects. He has various units in which the configuration manager uses. Again, your reliability, your maintenance, and your cost of the specific unit we're talking about. The mission management, these are going to be the people who actually try to look at what the capabilities are and make sure that all of the tasks are being completed, and they're the ones who make sure that the collection actually happens. What they're going to primarily use is the actual collection apparatus, whereas the configuration management is more of making sure that the components exist, are up and running and ready to be used. The mission managers actually are the ones who use the system itself. And then you also have your quality control. This will be a management. You'll notice the tilde next to all of these. These haven't actually come online yet, but we have a rough order of magnitude based off of what we're currently seeing in the field and what we plan on, how little we plan on SPICE affecting the overall management flow of the quality assurance. We have sites that have quality assurance already with the analysts, and ensuring that the tools the analysts are using to say if this collection was successful or not is the same tools that the collection sites are using to quality control their own work. Functional analysis baseline, our primary focus was SPICE primary functions, which was your management, your product, your configuration management, your collection and security. Meeting the requirements is going to be a pillar of making sure that SPICE is a successful system. And SPICE initial 3 focuses, which was going to be your MOP development and definition, making sure that collection is configured in a way in which it collects the most amount of uptime at the highest priority, and making sure that you have your error rates cut. In summary, we established the initial need for SPICE, we listed the objectives, we identified who the stakeholders are, we also explained the key functions and how they interacted, and we went over the list of the requirements. If you have any questions, please reach out to me. Thank you for your time.